So now I just want to go over some really quick rules, and these are going to be the rules that we're going to use for the octet rule. Okay? So atoms can satisfy their octet by forming chemical bonds or by possessing lone pairs. So what that basically means is that, remember that I said atoms want to either lose electrons or gain electrons in order to fit the noble gas configuration, right? Well, if you are losing electrons, that means you're going to be sharing electrons with other atoms. Okay, so that would be a bond. If you are gaining electrons, that means you're going to be taking on more electrons, so you might have like a lone pair on the atom. Okay, those electrons are called octet electrons. So keep in mind what an octet electron is. All right. So basically, let's talk about the first row elements: hydrogen, helium, and lithium. Okay, hydrogen, helium, and lithium are so small that they're usually only going to have just that one s orbital, and it can only have 2 electrons. Okay, or they're going to so basically what that means is that they're going to prefer to only have 2 octet electrons so that they can become like helium. Okay, so hydrogen is going to want to gain an electron, lithium is going to want to lose an electron so that they can both be like helium. And they're both going to want, basically, all of these are going to want to have 2 octet electrons. Cool so far? This is also known in some books as the duet rule. Okay? But the duet rule is the same thing as the octet rule. As long as you think of noble gas, it's the same thing. All right? So then we have our second row elements. So this is first row or first period, you could think of. Second row elements are carbon, nitrogen, oxygen, fluorine. These are all going to prefer to possess 8 octet electrons. That's why we use the name octet rule, common. Now it turns out there is an exception to that. The atoms that are smaller than carbon are going to prefer to possess less than 8 electrons. The reason is because they don't have that many orbitals, so it's actually difficult for them to accommodate 8 electrons. So Be or beryllium is going to prefer to have 4, and boron is going to prefer to have 6. These are just things you need to know. You just need to memorize that. Then finally, we have our third row or third period elements that are going to be able to form what's called expanded octets. Okay? This is what an expanded octet is. We talked about s orbitals and we talked about p orbitals. But it turns out that phosphorus and sulfur are so big that the p orbitals are going to get filled up. Do you know what comes after the p's? The d orbitals. We're not even going to talk about d orbitals in this class. But what you should know is that d orbitals can also hold extra electrons. So what's going to happen is that phosphorus and sulfur can choose to hold more than 8 electrons if they want to. So phosphorus is going to be able to hold 10 electrons, and sulfur is going to be able to hold 12 electrons.